This video will be about rational exponents. A rational has to do with fractions, so a rational exponent means when we have a fraction as an exponent. We'll begin by looking at one important property of rational exponents. That is that anything raised to the power of 1 over n is the same thing as taking the nth root of that number. We can make sense of this by looking at n equals 2 as an example. Remember that if we take the square root of x and we square that, then we end up with x. What if we take x to the 1/2 and we square that? Then we end up with x to the power of 1/2 times 2, or just x. These two are equal, so that means that these two are equal. And we can then prove this expression in a similar way for different values of n. Let's look at some examples. We'll start with 729 to the power of -1/6. Now from our rules about exponents, we know that we can rewrite this as 1 over 729 to the power of 1/6. We can rewrite 729 as 3 to the 6th, so then we have 3 to the 6th to the power of 1/6, or just 1 over 3. Another example, 343 to the power of 2/3. And I'm going to begin by telling you that the cube root of 343 equals 7. So we can take our expression and write it as 343 to the power of 1/3 to the power of 2, or the cube root of 343 to the power of 2. So then that means that's just 7 squared, or 49. Another example, the 12th root of 1,331 times the 4th root of 1,331. We can write this as 1,331 to the power of 112 times that to the power of 1/4. Now we can add the exponents, so we end up with 1,331 to the power of 1/3, which evaluates to 11. What if we had the cube root of 1,024 over the square root of 32? And I'm going to tell you that 2 to the power of 10 equals 1,024, and 2 to the power of 5 equals 32. Now we can rewrite our numerator as 1,024 to the power of 1/3, and the denominator as 32 to the power of 1/2. So that's 2 to the 10th to the 1/3 over 2 to the 5th to the 1/2, or 2 to the 10/3 over 2 to the 5/2. We can subtract our exponents, and that gives us 2 to the 5/6. 2 to the 5th is equal to 32, and we are taking that to the power of 1/6, so that's just the 6th root of 32. In our last example, we're going to use rational exponents to multiply by a conjugate. So we'll start with a to the 1/2 minus 3 over a to the 1/2 plus 4. The conjugate of the denominator is a to the 1/2 minus 4, so we're going to multiply both the top and bottom by that. And now, in our numerator, we're going to use FOIL. First terms multiplied by each other, plus the outer terms multiplied by each other, inner, and last. And that becomes a minus 7a to the 1/2 plus 12. And then our denominator is just going to be the difference of squares, so a to the 1/2 squared minus 4 squared, or a minus 16. And that means that our entire thing is just equal to a minus 7a to the 1/2 plus 12 over a minus 16.